We are today reviewing for your points of concurrency test. Let's get right into the fun and see what we can find out. Alright, using diagrams to find measurements. Well, this first one we have a perpendicular bisector. So what I should be looking for is, well, if the perpendicular bisector, that means these are obviously cut in half. So that means whatever HK is, JH must be the same thing. So this needs to be, for my answer here, this needs to be 8. Because HK is 8, JH is 8. Same thing with this. Whatever this diagonal is, your diagonal must be the exact same. So that has to be 12. And JK is the full big segment, so 8 plus 8, which gives me 16. Okay? In this one, we're looking for first the measure of QST, that's this angle right here. Well, it's an angle bisector, so both those angles must be equal to each other, both 55 degrees. And these two must be the exact same size as well, 23. So those are just based straight off of your theorems. Those two have to be equal, and then for the first picture, those must be equal as well. So those should be 5 easy points for you to do. Alright, next, our matching section. We're going to use here our little idea from that we looked at in class regarding just our table and to see what we can find out. In case you missed it, this is what that looked like, our table here. We can just look and say, well, what intersects at what points, what the pictures look like, what distances we can find out. So this would be something very beneficial to have and to know for your test here. So back to the actual problem. Let's look here and see, well, this first one here, we're going from endpoints to medians here. These are not listed as being perpendicular. We do not know that. We can't include that. So the midpoint to the vertices, those are medians. The median is the centroid. In this one, the circle is on the inside. That would be a in-center. Number 8, the center of gravity. We know that as the centroid. It is the balance point. Found where angle bisectors intersect. Angle bisectors come from, again, the in-center. Number 10, found at perpendicular bisectors. That comes from the circumcenter. It's the only time we'll have perpendiculars for sure. Intersection of the medians, what we said, same thing for number 6, centroid. Number 12, this picture, we got bisectors, and they are perpendicular this time, so that's why this one is the circumcenter. Number 13, we have angles being cut in half. Angle bisectors gives you an in-center. Number 14, the 2/3 ratio is the centroid, and the only one that could exist outside of the circle is the circumcenter, so A. So those, you're going to have another matching set like that on your test. Moving forward, now we're looking at a circumcenter. What we want to think with circumcenter is each side is being split in half, and each of these points from the middle to the corners, not the sides, but the corners must all be the same. So dy right here, well, it's the same side as xd, so they must be the same, 62. cz, the same as xc, it's 59. YZ, well, that's a full big long side, which means both need to be 45, which means they would add up to 90. PX and PZ are two of the segments that go from the center to the endpoint. So they must all be the same as PY, which is 63. 63. And the tough one here is PD, this segment right here. Well, here's what we're going to do. We're going to say, well, look, YB is 62. These are perpendicular bisectors, so it's a right angle. What do I have now here in this light blue is a right triangle. So to solve that right triangle, I'm going to use the Pythagorean Theorem. Well, my hypotenuse is 63, so that's the one that's got to be on my own. The other two are 62 and another leg I don't know. So a squared plus 62 squared equals 63 squared. So I'm going to get that a squared is going to equal, we would do whatever 63 squared minus 62 squared is. That means a squared equals the square root of 125, which is approximately 11.18 as my answer. So that's how I find that last side, anything going from the circumcenter to a side, I'll be using Pythagorean Theorem. And this, honestly, is probably one of the toughest problems on the test to be able to get that one. Okay? Now, the point of finding the circumcenter. So, first we need to go through, we're going to have all the steps mapped out, find the midpoint of each side. Well, midpoint of AB, I'm going to add up the x values. 1 plus 7 is 8, but then divide by 2 is 4. 2 plus 0 is 2, divided by 2 is 1. This one we get 3 and 8. And then for this one we should have 0 and, let's say 18, we should have 18, so 9. 0, 9. My slope here, the slope of AB. Subtract the y's, I'll do 2 minus 0, over, subtract the x's, 1 minus 7. So, 2 over negative 6, which can reduce to negative 1/3. For BC, we're going to do the same thing. Y's are 16 minus 0, the x's are negative 1 minus 7. So that means 16 over negative 8, which gives me a negative 2 as my slope. And then for AC, I'll do 16 minus 2 over negative 1 minus 1. 16 minus 2 is 14. Negative 1 minus 1 is negative 2. So I should get negative 7 for that. So to find now the perpendicular slope, what I need to do is take the opposite reciprocal. So all these end up being negative in this case, so they're all going to be a positive number. And the reciprocal is to flip the fraction. So this becomes a positive 3. This becomes a positive 1 over 2 and a positive 1 over 7. Now I need to find the equation of all of these lines. So for each one, I will start with y equals mx plus b and plug in what I know. Y equals mx plus b, y equals mx plus b, y equals mx plus b. Plug in what I know. Well, my y comes from this midpoint. So I'm going to plug in 1. My slope is 3. My x is 4 plus b. So 1 equals 12 plus b, which means b equals negative 11. So my slope, or my equation for this one should be y equals 3x, my slope 3, minus 11. The second one here, we're going to do the same thing. The y value is 8. The m value is 1/2. My x is 3 plus b. 8 equals 3/2 plus b. That means that when I subtract, I get 6.5 is equal to b. So my equation here should be y equals 1/2x plus 6.5. And then this last one, we're going to see what we get. Y equals 1/7 times 0. X is 0 up here. My y value is 9, so I'm going to plug in 9 there, plus b. So 9 equals 0 plus b. So I get 9 equals b. So that means that my equation here should be y equals 1/7 x plus 9. So which equations look nicest to work with? I would probably say these two, even though this one does have a decimal for b. 1/2 is a lot nicer than 1/7. But no matter which equations you use, you should be able to make them work out. So I set 3x minus 11 equals 1/2x plus 6.5. I'm going to get, if I add a half, so I'll get 3.5 x's over here. And I should have subtracted. My apologies. I need to subtract a half x, so I get 2.5x. And then when I add 11 to this side, I get 17.5. Divide both sides by 2.5, and I get x equals 7. Then, to find y, plug it back in. So I'm going to plug it back into this equation because it looks nicest. Y equals 3 times 7 minus 11, which equals 10. So my final answer should be in the ordered pair, 7, 10. So, long, tedious process, but this is also the one that is worth most points on the test. Okay, now we move to incenter. We need to find the incenter coming up. First, we need to use a diagram. So, the incenter means that from the middle, from the incenter to each side is the exact same distance. So which one tells you going from the middle to a side? That would be 16 here. So 16 is the distance to all 3 sides. The measure of CAG, that's this angle right here. Well, incenter deals with angle bisectors. So if that's 22, that means this one has to be 22 as well. The last one, angle FEG, that's this angle right here. How do I find this? Well, I have 64 here. I have 22 and 22. How much is left? Well, that means I do 180 minus all of that. 64, 22, and 22 is 108. That leaves me 72 degrees left for the entire big angle here. But I want just one of those. So 72 divided by 2 gives me 36 degrees. The last one, segment of, or distance for length of segment AF, I'm going to have a right triangle there. So same thing as before. A squared plus 16 squared equals 34 squared. And when I do that, I should get that a squared ends up being the square root of 900, which means when I take that square root, a will equal 30 for my answer. Now, to find the incenter, what we're going to do, we need to find the length of each side. When I do side A, I'm looking at points B and C. Side B gives me A and C. Side C gives me A and B. The formula is you take the square root, you need to subtract the x values of B and C. So subtract 14, 14, that's pretty easy, and square it, and then subtract the y values. So 44 minus 17, and square it. Add them up and take that square root. So I end up getting the square root of whatever 27 squared is. Well, the square root of a square is just what you started with, 27. For B, I look at points A and C. So I should have negative 6 minus 14 squared plus negative 4 minus 44 squared. When I simplify that, I should get that this is 400 because this becomes 20 squared, and this other one is 2304. When I add those up and take the square root, I should get 52. And then side C, same thing. I'll have here, I'm going to do 14 minus a negative 6 squared. That'll become 20 squared. And then the second part is 17 minus negative 4 squared. That should become 21 squared. So I should have 400 plus 21 squared is 441. The square root of that, of 841, is 29. So that means I also need one more thing. I need to know my perimeter. Perimeter, adding all three of these up, is 108. Now, using the incenter formula and using it correctly, we need to do the following. We're going to have a big ordered pair here, essentially. So, I need to first do my distance of A, so 27, multiplied by the x value of A, times negative 6. Then we're going to add 52, which is the distance of B, times the x value of B, which is 14. And then finally, add 29, the distance for C, times 14, the x value for C. Then divide that by the perimeter, 108. Same thing for the y part, except we're going to need to do the y values instead of the x values. So in this one, it should be 27 again is the distance, times the y value of A is negative 4. 52 is B, times the y value of B is 17, plus 29 times the y value of C, which is 44. Again, divided by 108. And when I plug that into my calculator and plug and chug, make sure you do the whole numerator first. This becomes 2052 up top. This becomes 972 up top. Those divisions give you 9, 19 as my answer. Alright, home stretch, we're on to the centroid. Alright, in this one, we start with SL being 63. That means that the whole thing is 63. Each of the three pieces is 63 divided by 3, which is 21. So, the smaller piece goes from the center to the side. So CS needs to have one piece, 21. CL needs to have two of those pieces, 42. And check yourself, 42 plus 21 does equal 63, so we're good. Now, the other part it tells you CR is 26 here. Well, 26, would that be the smaller piece or the bigger piece of the inside? It's the smaller piece because it goes from that to the side. So that means 26 is the small piece. That means times 2 to get the bigger piece is 52. That's what NC is, 52. And then the whole big long segment, and I would just add 52 and 26 to get 78. So check those because those were marked incorrect on your answer key, so make sure you have those two fixed up properly. The last thing we have to do is find the centroid. Very similar to doing what we did before with the circumcenter. Start with the midpoint, -1, -1 here, because I do, for A and B, add these up, -2 divided by 2 is 1, and the same for -3 plus 1 gives me -2. So divided by 2 to get -1. Similarly, 8, -6, and 2, -8 for my other two midpoints by adding them up, dividing by 2. For my second point, my point opposite, if I'm doing segment AB, I want to use point C here. So I'm just going to rewrite point C, 11, -13. This one, BC, I want point A, so -7, -3. And then for this one, point B, I'm going to do, just rewrite 5, comma 1. And now to do the slope, I'm going to do the slope between these 2 points that I just found. So my slope here should be, subtract the y's, minus a negative 1, over 11 minus negative 1. So I should get on the top, negative 12 over positive 12, so my slope there is negative 1. In this one, I don't need to do the opposite reciprocal stuff like I did with circumcenter. Here, negative 6 minus negative 3 for my y values, and then 8 minus negative 7 for my x values. Negative 3 over, it should be, if I did negative 6 minus negative 3, 8 minus negative 7, 15, so negative 1 over 5 as my answer. And my final slope here should be 1 minus negative 8 over 5 minus 2. So that should be 9 over 3, or just 3. Write the equations. Again, y equals mx plus b. So plug in what I know. Y, I can use either one of the points. So I'll do negative 1 equals negative 1 times negative 1 plus b. Negative 1 equals positive 1 plus b. So b equals negative 2. So y equals negative x minus 2. This one here, y equals mx plus b, I'll plug in negative 6 for x, or for y I mean, equals 8 times negative 1/5 plus b. I can tell already it's going to be ugly, I probably won't use this one. My final answer though is negative 1/5 x minus 8/5. And this one right here, find the equation. Y, I'm going to plug in 1, x will be 5, 3 for my slope, plus b. So negative 14 will equal b, y equals 3x minus 14. Set those equal to each other. Negative x minus 2 equals 3x minus 14, because these are the two that are much better looking. I'm going to add an x to both sides to get 4x over here. I'll add 14 to get 12 over here, means 3 equals x. I'll then plug back in, so y will equal negative x minus 2. Y equals negative 3 minus 2, so y is negative 5. My ordered pair, 3, comma